What did 13 say? Like this? What was the base? No, it's not. Okay. So were you supposed to rewrite this in exponential form? So that would be 10 to the cube root of 8 equals 2. That doesn't make a whole lot of sense, does it? Oh. That's not either? No, I want the actual problem. Cube root of 8 equals 2. All right, so how do you rewrite this using exponents? Around 1/3. Now we're ready for log form. So what's the base? No. 8. What's the answer? 2. What's the exponent? Yes. Other questions? This is your last opportunity to ask questions before your quiz. 41 said?
8 log 8 to the log of 8 to the 19 equals x.
You mean like up here?
Or 8 just 19, regular math.
Oh, the base.
Yeah.
So it is base 8 of 19 equals what?
X.
Equals x. All right, so if I were to put this in logarithmic form, okay, it would be log, what's the base? And 8x is not the base. 8, what's the answer? What's the exponent? Log base 8 of 19. So this is a situation, is the log base 8 the same? So in order for those to be equal, what can we say about x and 19? They're equal. Which brings us to a property. Notice this was 8 as a base, and the base of the log was the same as the big base. You with me? And what did the answer end up being? Oh, look at that. So if I have 4 log base 4 of y equals x, what does x equal? It equals y. Let's do this again. We would put this in log form. This is not in log form because it's 4 raised. What's the base? 4. This is the base. What's the answer? What's the answer? X. What's the exponent? Log base 4 of y. So if this log is the same as this log, what must be true? X equals y. All right, so if I have e raised to the natural log of 3 equals x, can you tell me what x equals? X equals 3. Why? What's the base of ln? E. So if I were to redo this, I would say natural log of the base, which is, so e. What's the answer? X. What's the exponent? No. All of that. ln 3. Now, are the bases the same? So what must x equal? 3. So when the base of the exponential piece is the same as the base of the logarithm exponent, this is what happens. So if I have log base 5, no. If I have 5 raised to the log base 5 of 2 equals y, what is y? Y equals 2. Why does y equal 2? The base and the base of the log are the same. would be log base 5 of y equals log base 5 of 2, which means y equals 2. That's one of the properties. That's just kind of, how do we say, foreshadowing of what is to come. Any other questions? That definitely, I think, was the hardest question in your homework. All right. So, oh, let's see. What are we doing today? Oh, we got a graph using transformations. So I believe today is all about transformations. Tomorrow's all about properties. So let's see what, here we go. So what are we going to do? To graph a logarithmic function using transformations. My suggestion is to make it, yes, my suggestion is to make a table for the exponential function because that's easier. That's the inverse of the parent log function. Then switch the x and the y values so you have the table for the log function. And then plot those points. So at this point you have what we call the parent function. And from here you all know what to do. Then you use transformations to transform the parent graph into the graph requested. And you all have had practice already on doing the exponential table and then finding the logarithmic table. Usually negative 2 is just so tiny. You know what I mean?
Yeah.
1/16, 1/3, 1/4. So we're going to start, we're going to take the logarithm, turn it to an exponential function, make that table. Then we're going to reverse the ordered pairs. Okay. So here's our first one. What would be the parent exponential? What's the base? Right. So it's going to be y equals 2 to the x. So we've got x's, we've got y's, we've got negative 1, 0, 1, 2. What's 2 to the negative 1? 1/2. What's 2 to the 0? What's 2 to the first? 2 to the second. Okay, so now this is the logarithmic log parent. So the log parent is going to look like, notice I don't graph those. What am I going to do? So it's going to be 1/2 negative 1, 1, 0, 2, 1, 4, 2.
So do you just leave off the x plus 2 when you're finding the parent exponent?
Right. I mean, yeah. So the parent log graph would be f of x. Well, maybe I should make that a different. It's not going to be f because that's f. The parent log would be y equals log base 2 of x. So now we're going to get to go negative 1. We go up 1/2. We go 1. Oh gosh darn. I did not do that well at all, did I? We go over 1/2, down 1. We go over 1, up none. We go over 2, up 1, and over 4, up 2. Now, where's the asymptote? On the log function. X equals 0. That's where our parent asymptote is. So the question is, what did now? We've got that. What did the plus 2 do? Okay, so what happens to this asymptote then? It goes to the left also. So we're going to go 1, 2. And every other point does what? To the left, 2, to the left, 2, to the left, 2, to the left, 2. Am I finished? Except I didn't do a very nice job on connecting. Oh, darn, yes. You think we're done? What? I'm ready.
You said are we done, and I feel like that's a trick question.
No, we're finished now. Making sure. All right. Let's do another one. What's this parent? The which one? No. We just do this table to get our log table. Okay, so again, we're at y equals 2x. So, you know, if they kept it all the same, then you only have to do the exponential table once, right? 0, 1, 2. We said this was a half, 1. What was this? 2, 4. So now we need the parent log, which is log base 2. So to get the parent log, it's going to be 1 half negative 1, 1, 0, 2, 1, and 4, 2. All right, so over half down 1, over 1 up none, over 2 up, over 1 up 2, over 4 up 2. Asymptote right here. All right, no flip, right? All right, so what does this tell me to do?
To the right 3.
1, 2. 1, 2, 3, 1, 2, 3. All right, what happens to my asymptote? 1, 2, 3. Now what happens? We're going to go up 1. So this goes up 1. I'm in green now. This goes up 1, this goes up 1, and this goes up 1. Notice, watch, if I try to move my asymptote up 1, does it really change? No, but the left or right did make a change. All right, so now I need to try to go through my green points. Ooh, not bad, though it shouldn't curve that significantly. What are you thinking? Hard or easy?
I don't like them.
You don't like them?
I said I don't like them.
Okay. You know, you get the transformations down, then it's just a matter of the new parent graph. You with me? Gosh, why am I doing everything base 2? Let's change it. Let's do 3. Why do I want to think that it's going to be all the same base? So y equals 3 to the x is our exponential, correct? The exponential is determined by the base. Negative 1, 0, 1, 2. So this is going to be 3 to the negative 1, which is 1/3, 3 to the 0, 3 to the first, 3 to the second. What does your parent log function look like? Log 3 of x. All right, so it's going to be 1/3, negative 1, 1, 0, 3, 1, 9, 2. So now I go over 1/3 down 1, over 1 up none, over 1, 2, 3 up 1, 3, 4, 5, 6, 7, 8, 9 up 3, right? And what do I have? Did I do that wrong? 1, 2, because that's 10. So there are my points. What do we do first? Over the x-axis. So this point would come up to here. That stays. This goes down. And this is up 3, so now it's down 3. So we're looking at the orange. And now what do we do? Down 2. Oh, let's do purple. So we go down 2, down 2, down 2. Oh, that fit. So now I got to try to draw it this way. Well, okay. So, yes, the asymptote did not move because if I'm going to shift it vertically down, is it going to get off that y-axis? No. You might actually be able to start your homework. Oh, of course you have a you try. So I think, I think we want 1. Yeah, you gotta graph it. If you guys, yeah. So if you have a scrap sheet of graph paper, that would be great. There, can you read it?